Okay, guys, happy Monday. Hope you had a great spring break. We're continuing with functions. I'm on 6.2 on page 161. I want you guys just to kind of go through the video first and then go back and fill in the notes. Okay? So, investigating a change or a constant rate of change. The U.S. Department of Agriculture defines heavy rain as rain that falls at a rate of 1.5 centimeters per hour. So, this is already down to 1 unit rate. If you take a look here, it says the table shows the total amount of rain falls in various amounts of time during a heavy rain. So obviously, when there's no time, there's no rain yet. Okay, when you start counting the time in 1 hour, they gave us this. It was 1.5 centimeters per hour. So we know what the unit rate is. We're going to multiply everything by 1.5. 3 times 1.5, 4 times 1.5, and then 5 times 1.5. It says plot the ordered pairs from the table on the coordinate plane at the right. Remember, that's my x and that's my y. And you know that because the amount of rainfall depends on the time that went by. So if you take a look here, my x and my y, the amount of rainfall depends on the time. So I just went ahead and plotted this, and you can see here there's a linear proportional relationship. It says how much rain falls in 3.5 hours. I just went, oh, they didn't have it in the graph, but I just went ahead and multiplied 3.5 hours times that unit rate, 5.25. I tried my best to graph 5.25. It's really hard because here's the 5, so it's not quite 5.5. It's about as best as I could do. It says plot the point corresponding to 3.5 hours, which I did. What do you notice? It's linear and all points are on a line. Remember, linear, the base word is line. All points are on a line. Is the total amount of rain falls a function? Remember, we talked about functions 2 weeks ago. Of the number, yes, it is a function because if you take a look here, every x only has one y. Okay, there are actually values here. I really should probably connect the line, right? Because rain also falls at 1.5 hours and 2.5 hours and so on. So that is considered a function. So now we're just kind of adding. The only thing that's new is we're just adding that word. Remember that a function means that every x only has one y. Suppose you continue to plot points for the times in between those dots that every, you would fill in the gaps along the line. That's why I said you should connect the dots, right? So if you do 0.5 hours, it would be here. There's a value. That's why it's probably a good idea to go ahead and connect those dots. Okay. It says the relationship you investigated in the previous activity can be represented by the equation y equals 1.5x. Remember, there was no y-intercept. So there's no b, right? It's just 1.5 per every hour. It says where x is the time and y is the total amount of rain, and the graph of the relationship is a line, so it's linear equation. These are all things you know already. But since there's only one y for every x, you could also say it's a linear function. This is the only thing that's new. It's a linear equation and a linear function. So let's take a look here. You can tell already there's a y-intercept, right? But as long as it follows that y equals mx plus b, it's considered a linear, okay? But let's take a look here. It says the temperature at dawn was 8 degrees Fahrenheit and it increased steadily at 2 degrees Fahrenheit every hour. So here's the equation. It started at 8 degrees Fahrenheit and it went up 2 degrees every hour, so 2 times x. Total temperature is y. X is the hours. State whether the relationship between the time and the temperature is proportional or non-proportional, and graph the equation. You should be able to tell already. They graphed it for you if it's proportional or not, because it doesn't go through 0, 0, so it's non-proportional. Okay, so if you take a look there, they just plugged in some values for x to get the y, and then they plotted them, and then they graphed them. Okay, it says since b is not equal to 0, remember b is plus 8, the relationship is not proportional. Remember, 2 would also be considered the slope. slope of the line. So state whether the relationship between x and y in this is proportional or non-proportional, and then graph it. So I said when x is 0, so I put a 0 in here, y would also be 0, because 0.5 times 0 is 0. So we know it's already proportional because there's a 0, 0. Then I just did a little bit, I plugged in some positive values for x and then some negative values for x. So I went ahead and multiplied 1 times that, 2 times that, -1 times that, -2 times that. Plotted them. Realize it's proportional because it goes through 0, 0, and there's no b. There's no y-intercept here. This is in y equals mx plus b form, and there's no b. So it's proportional. Okay. Determine whether a function is linear. Okay. The linear function in example 1 had the form of y equals mx plus b, where m and b are real numbers. Every equation in the form y equals mx plus b is linear. Okay, a linear equation represent linear functions. Equations that cannot be written in this form are not linear and therefore are not linear functions. It's not that it's bad or wrong. You could tell right here, this is not linear. It's curved. And look at the initial equation here. It says the equation y equals x squared. That is not in y equals mxb form because the x is squared. So again, if you just go ahead and plug in values for x, you'll get a y. And if you start plotting them, you'll see that this starts to curve. Only a linear relationship can be proportional. So the relationship is not proportional. Okay, there isn't going to be a constant. Take a look here. A soda machine makes 2/3 gallon of soda every minute. The total amount y that machine makes in x minutes is given in this equation. It starts at 0, 0, so it is proportional. They went ahead and gave you an x. In this case, they gave you a y, so I'll show you what I did here to figure this out. I'm using this equation, so look here. I'm going to put the 0 in here, so obviously the y is 0. I'm going to put the 3 in here, so let's look. Okay, that was the first one. I put the 3 in here, the 3's crossed out, I'm left with the 2. But in this case, they gave me the y, so I have to solve for x. So 4 equals 2/3 x. So remember from last year, you guys would go ahead and multiply by its opposite. So I multiplied 2/3 times 3 over 2, multiplied 4 times 3 over 2 to get 6. Because if you look 3 over 2, this would cross out, and you're left with the x. 3 over 2 times 4, the 2 and the 4 cross out, so you're left with 3 times 2. And then plug the 9 in for the x, so obviously the 3 and the 9 will cross out to give you a 3 times 2, which is 6. And I just went ahead and plotted those. Okay. Today you are going to do page 164 and take a picture, but you will also take a picture of pages 161, 162, and 163, so I know you copied the notes down. Okay, have a great Monday.